Hi, I'm Jenna Larson, and this is my video for Lab 1 of Physics 2212, where we'll be looking at charge tapes. So a little bit about this lab before we get started. The main purpose is to observe the interactions between two different pieces of tape based on their respective electric charges to see whether they're repelled or attracted to each other. And then we're also going to create two computational models in GlowScript of these tape segments and their interactions, and we're going to compare those resulting charge magnitudes. Some of the fundamental principles that we'll be using are Coulomb's law, Newton's second law, and gravitational force. And then just a little preview of our results. From our point charge model in GlowScript, we got a charge of 1.26 times 10 to the negative 8th coulombs per piece of tape. And then for our line charge model from the second computational model, we got a charge of 2.6 times 10 to the negative 8th coulombs. And going back to our first computational model, we also calculated the number of electrons lost by the piece of tape, and that ended up being 1.16 times 10 to the 11th electrons. One more thing before we get into the nitty-gritty of the experiment, just a couple assumptions that we've made. One is that air resistance is negligible. Two is that the charge is concentrated in the exact center of each piece of tape. And then we're also assuming that the large strip of tape is equivalent to a point charge and that each strip of tape has an equivalent charge, so each is equally charged. So to start this experiment, we started by laying out one flat piece of tape stuck to the table, and then we got another piece of tape. This one ended up being about 0.16 meters long. So we stuck that onto that first piece of tape and then quickly yanked it off to give it a good positive charge. We stuck that piece of tape so it was hanging off the edge of the table by itself, and then I rubbed my hand in my hair to give it a negative charge and held that hand up to the tape and saw that the tape was attracted to my hand, meaning that the tape is positively charged, as I presumed. And then for the second part of the experiment, we made a bridge out of a charged piece of tape and then made a second charged piece of tape and held it up underneath the bridge of tape to see at what distance those two pieces of tape started repelling each other. And so just kind of a little bit of our system setup. We have tape A and tape B as our system, and then surroundings is just everything else. And then our starting conditions, we are assuming that the electric charge is 0 on the tape before we charge them up. All right, so here we can see our first computational model. On the left side of the screen is the code that I created, where I had the tape mass, the tape width, and the tape length all shown here, as well as the distance at which the tapes started to repel each other. And then the rest of the code is what I used to create this computational model over here on the right side of the screen. And as you can see, the calculations that we did within the code resulted in a charge on an individual piece of tape being this, the deficiency of electrons per piece of tape being this value, and then we also found a third fun value of the number of atoms per electron on each piece of tape. And now we have our second computational model. On the left side of the screen again, we have the code that was written and that I tweaked. We can see the mass that I used as well as the charge that I calculated and estimated. And then down here is the code that I used to create the electric field or to calculate it. And then on the bottom of the screen are just the scale that I used for the arrows just to make it a little more visually pleasing. And then on the top here in the middle is just most of the code. That's kind of where all the meat of it is, really for the arrows and everything that we see on the right side of the screen here in the resulting image, where it also tells us the magnitude of the electric force is this, and the magnitude of our gravitational force is this. Lastly, if we were to switch the signs of electrons and protons, the only real difference we would notice is on the diagrams and labels that we draw, as like charges would still repel each other and different charges would still be attracted, so not a whole lot would change. And then comparing the two values that we calculated, the point charge versus the line charge values, the line charge one is larger and also more accurate, as a piece of tape is more similar to a line as opposed to just a big wadded up ball. Now, if you were to wad up the tape into a ball, it would be accurate. but that's not what we're doing in this case. And then lastly, just a couple error sources, just some inaccurate measurements. My hands might have been shaking, just touching the tapes too much, transferring my own charges from my body and doing all that stuff. And then the charge not evenly being distributed. All right, that is all I have. Thank you so much for your time.